Home inspector safety and dangers. Electrical portion of the house. Home inspection is one largely unregulated industry whose professionals must nevertheless be aware of their safety and that of their clients at all times. Part of this awareness is being mindful of one's surroundings, which can be challenging because of the workplace changes with every appointment. Aside from inspecting a roof from an area above the ground, the electrical portion of a home inspection is arguably the most dangerous. Many things can go wrong in an instant, and some mishaps can be fatal. That's why, even as generalists, home inspectors should understand what causes electrical shocks and arc flashes so they can avoid them. The basics. The typical electrical service for homes in North America is a 120 240-volt split-phase system provided by a pole-mounted distribution transformer located at the service drop, which is made up of two 120-volt lines and a neutral line. This triplex cable may include a messenger cable located in the middle of the neutral conductor that provides support over long spans. The neutral line from the pole is connected to an earth ground near the service panel, which is usually a conductive rod driven into the earth. The service drop provides the home with two 120-volt lines of opposite phase, so 240 volts can be obtained by connecting a load between the two 120-volt conductors, while 120-volt loads are connected between either of the two 120-volt lines and the neutral line. The 240-volt circuit is used for a home's electrical appliances that require substantial power, such as a furnace, water heater, air conditioner, washer and dryer, and oven range. The 120-volt circuit is used for lighter electrical loads, such as household lighting and portable appliances and electronics that are plugged into the home's standard 2- or 3-prong, without a grounding wire, electrical receptacles or outlets. Homes in European countries use 3-phase power, having longer service drops that can serve multiple residences. Homes in European countries use 3-phase power, having longer service drops that can serve multiple residencies, which is an economical approach to providing power to dense populations in small areas. This type of service drop consists of 3-phase wires and one grounded neutral wire. How an electrical circuit works. Everyone should understand that it's possible to receive an electrical shock whenever electrical power is present, regardless of the level of power or the presence of any protective devices. An electrical circuit requires a minimum of 2 wires through which electric current in the form of electrons flows. Current is measured in amperes, amps for short, which travels from a power source, such as the local utility, through the device it operates, called the load, and then back to the source to complete the circuit. In AC, or alternating current wiring, there are about 120 volts in the hot or energized wire. This voltage provides the momentum that forces the electrons to flow in the circuit. The power switches on electrical devices are wired on the hot or live side of the circuit. The return conductor, known as the neutral, is at 0 volts because it is grounded at the electrical panel. Most 120-volt circuits are wired to deliver 15 or 20 amps of current. How injuries occur. Modern electrical systems are wired with circuit breakers or with fuses in older construction. These devices serve as overcurrent protection and are rated in amps. Most household circuits are wired for 15 or 20 amps. Overcurrent protection devices are designed to protect the electrical system's wiring and equipment from overheating, but they may not protect a person from electrical shock, which is why any type of component in the system should be approached with caution. By coming into contact with a live load or energized wire, a person's body, even a finger, can complete a circuit by connecting the power source with the ground. If this happens, it's likely that the person will sustain an injury. Most fatal injuries result from high voltage exposure, but it's possible to incur a severe injury from low voltage power if it has a high current flow. Even if the current isn't high, a person could be shocked or even electrocuted without ever tripping a circuit breaker or blowing a fuse. Currents of 50 to 100 milliamperes can be fatal. Standards of practice. According to InterNACHI's Home Inspection Standards of Practice, the inspector is not required to Measure or determine the amperage or voltage of the main service equipment. Remove panel board cabinet covers or dead fronts. Insert any tool, probe, or device into the main panel board, sub-panels, distribution panel boards, or electrical fixtures, or operate any electrical disconnect or overcurrent protection devices. However, some inspectors may choose to go beyond the standards of practice because they suspect some sort of defect and want to provide fuller information in their reports for their clients. Warning signs. Nevertheless, there are warning signs that a panel, box, or the system in general may be compromised, and these should persuade the inspector to defer further evaluation to a licensed electrical contractor. Warning signs include scorch marks on the dead front or the panel board door indicating a past or recent arc flash. Rust, which indicates past or recent moisture intrusion. Missing or open breakers that cannot be confirmed to be de-energized. Overloading of the circuits with DIY wiring. Uninsulated wiring. Excessive dust, dirt, and debris inside the panel board and/or any signs of water inside, around, or below the panel board, which can lead to shock or electrocution. What's an arc flash? An arc flash occurs when a flashover of electrical current leaves its intended path and travels through the air from one conductor to another, or neutral, or ground. It often happens unexpectedly and can be explosive but brief, or it can last seconds and be rather visually spectacular. It can cause a little damage, or it can disable a system and require the replacement of equipment. An arc flash of any size is quite dangerous because its path is unpredictable. It will be attracted to the nearest item with the greatest conductivity, such as an unsuspecting rodent or house pet or a person. An arc flash can cause a serious electrical burn or even fatal electrocution. An arc flash can have various catalysts, including excess dust, condensation, corrosion, component failure, faulty system installation, dropping a metal tool which may cause even a small spark, and/or accidental contact. How serious is an arc flash? There are 3 factors that will determine the severity of an injury caused by an arc flash: proximity, temperature, and the time it takes for the circuit to break. An injury due to an arc flash can be quite serious because of the violent nature of such a powerful burst of electrical energy. The light from an arc flash can be blinding and disorienting. The heat caused by an arc flash can be as high as 35,000 degrees Fahrenheit, causing serious contact burns as well as risk of catching fire. It can create a blast pressure of up to 2,000 pounds per square foot, sending damaged and superheated electrical components flying through the air like shrapnel, with a sound blast as loud as a gun firing, which is 140 decibels. Combine all these unexpected jolts of sensory overload and the physical consequence can be impossible to avoid. In addition to the inspector being blinded, temporarily or permanently, and/or severely burned, another result of an arc flash is that it can set electrical components on fire, and the proximity of the inspector means that they'll likely inhale toxic vapors, which can cause respiratory and neurological damage depending on the duration of exposure. Also, the force of the shock wave can rupture eardrums. Furthermore, being shocked by a current above 75 MA can cause the inspector's heart to go into a state of ventricular fibrillation, which causes it to beat irregularly and rapidly without pumping any blood. If this condition doesn't quickly normalize, either by itself, using CPR, or with the aid of a defibrillator, it may lead to a heart attack, which can be fatal. If the brain is deprived of oxygen for more than 3 minutes as a result, this too can be fatal, or it can land the inspector in a vegetative state. It is not uncommon for an inspector to never fully recover their previous quality of life after experiencing an injury from an arc flash. Precautions for inspectors. 1. Assess your risk tolerance. You are not required to perform an invasive electrical inspection. Removing the dead front of the electrical panel board exceeds InterNACHI's standards of practice. Even if a home inspector is highly confident of their technical training as well as the situation, and they can also confirm that the system is de-energized, any suspected problems that require an invasive inspection should be disclaimed and deferred to a licensed electrical contractor. 2. Wear PPE. Regardless of whether you choose to exceed the standards of practice, always have available and wear the appropriate PPE, including fire-resistant clothing and insulated gloves made specifically for working with electrical equipment. It's also wise to use protective eyewear. Even a small spark can cause a severe eye injury. 3. Check your surroundings. If there's a lack of ground fault circuit interrupters, GFCIs, or if there is evidence of a water leak or moisture intrusion, or if the panel board or electrical box has scorch marks potentially indicating a previous arc flash or electrical fire, pay attention to these and other clues, as they may lead you to immediately defer the electrical portion of your home inspection. Again, assess the risk and then decide whether to proceed. 4. Use the appropriate tools. According to InterNACHI's standards of practice, inspectors are required to test all ground fault circuit interrupter receptacles and circuit breakers observed and deemed to be GFCIs using a GFCI tester where possible. Make sure your tester is working properly before your inspection appointment. An infrared camera is also a tool for helping to detect hot spots during the electrical inspection. 5. Protect your clients. Many inspectors encourage their clients to accompany them during the inspection so they can point out important shutoff valves and switches and discuss maintenance items. However, inspectors should use extreme caution when deciding whether to have the client with them during inspection of the panel board if signs indicate that it may not be safe. This is true for any area of the home that exhibits signs of instability or some apparent hazard. Using the InterNACHI Stay Back stop sign, available from Inspector Outlet, can help keep clients, their family members, and their realtors away from an inspected area. It's also useful for limiting the inspector's liability if the client chooses to ignore your warnings and suffers an injury during the inspection. Summary: arc flashes are just one of the more serious examples of what can go wrong during an inspection, which is why inspectors should follow their training as well as their instincts and protect themselves and their clients on the job. It's always better to be safe than sorry and incur a grievous injury, which can put both your livelihood and your life at risk.